Question 3, we have a particle moving along a straight line with acceleration given in this format. And v is 0 when t is 0. We're told to use integration by parts or otherwise. Calculate v when t is equal to pi over 2. So you're going to have the tables beside you, integration by parts, and the integrals that we will require up here. So if we set this up from here to say that dv dt is equal to t squared sine 2t, we can write dv is equal to t squared sine 2t dt. You could obviously do this in one step, and if we integrate both sides, the left hand side will give us v. So we need to simplify the right hand side down using integration by parts, LATE. Just be careful to put the trig after the algebra. So that's my u and my v. Algebra comes first, so we're going to let u equal t squared. So du dt is equal to 2t. We want du is equal to 2t dt. And then from integration by parts, we're looking at the integral of u dv. So we have that dv equal sine 2t. And if we integrate dv, we get v. Different v than the one on the left. We're kind of just simplifying this one. So v is equal to, if we integrate sine, what do we get if we integrate sine? We get minus cos. So we're going to get minus cos 2t over 2, 1 over the differentiated angle. So that's v, and we have du. So now we have to, it might be handy to write it out, the integral of u dv is equal to u times v minus the integral of v du. So we have to write it now in this format. So u is t squared from here, t squared times v, which we've just gotten to be minus cos 2t over 2. I'm going to put the minus in front and write cos 2t over 2. So that's fully simplified now. We can use that, but we will have an integral in the second part, so it's minus the integral of v, which is already a minus, so we can change it to plus the integral of cos 2t over 2 du, which is 2t dt. And the 2's will cancel here. So we're left with minus t squared cos 2t, which we'll keep to the end, over 2, plus the integral of cos 2t times t, don't forget it's in there, dt. So now we just have a second integration by parts, hopefully, to get us to the solution. So this is taken care of. We'll come back to this in a minute. So now again we have a u and a v. Let u equal t. So du dt is equal to 1, or du is equal to 1 dt, or just dt. We're going to let dv equal cos 2t. So the integral of dv will be integral of the right hand side. So v in this case will be, if we integrate cos, we get sine. So we're going to get sine 2t over 2. And if we sub this back into u times v, we're going to get t for u times v, which is sine 2t over 2. And then we're going to have minus the integral of v, which is sine 2t over 2, du, which is now just dt. So we can simplify this guy on its own. There's no parts involved. And if we integrate sine, we get minus cos. So this is now fully taken care of, and we can simplify this guy to get minus cos, and we already have a minus, so it's going to be plus cos 2t over 4. So this is v, so v is equal to 0, and we're getting t when between pi over 2 and 0 is pi over 2. Yeah, pi over 2 and 0 are the bands here. So we're going to get v minus 0, or just v, is equal to, so I'm subbing pi over 2 into these three expressions, the ones with the ticks, so 1, 2, 3, and then I'm subbing 0 in. So I'm going to get minus t squared, which is pi over 2 to be squared, by the cos. So I'm just subbing in t squared here, by the cos, and pi over 2 is equal to 90. So I'll do it in terms of degrees. So we're going to get the cos of 180 over 2. Cos of 180 is minus 1. So that's the first one subbed in. Then we're going to get this one. So we're going to have plus pi over 2 for t by the sine of 180, which is 0. So that's going to be equal to 0, this whole expression. And then we're going to have plus the cos of 2t, the cos of 180 over 4. That's the first part, that's subbing pi over 2. And then we're going to have minus, we're subbing 0 in. So in the first one, we're going to get 0 in here, will just be 0. The second one will have a 0 here for t, will be 0. Then we're just going to get the cos of 0 is 1, so we'll just 1 over 4. So we're going to get 0 plus 0 plus 1 over 4. So what does this give? This gives minus pi squared over 4 times the cos of 180 is minus 1, minus 1 over 2. This is 0. And then the cos of 180 is minus 1, so minus 1 over 4. And then another minus 1 over 4. So that's going to give plus pi squared over 8 minus 1 over 4, 1 over 4 minus 1 over 2 for the end of this integration by parts question. As a decimal, it approximates to 0.73, and we're dealing with velocity, so this is the speed, isn't it? Calculate v, so meters per second, for the end of this one. In part B, we have two identical smooth spheres, so there's going to be no change here. Which direction is there no change? So there's no change in the j. We're looking at them impacting along here. So what about the velocities? So we're going for a into the positive positive. So a is going to be u cos a. I'll just change alpha to a in the I direction plus u sine a in the j direction. That's before. They're identical, so their masses are both m. Then after, we're going to have, well, we don't know what it is. The I direction, the j is going to be unchanged. For b, it's just coming into the, it's going negative positive up into this sector, so minus u cos alpha in the I direction plus u sine alpha in the j direction. We don't know its velocity afterwards, and we know that the j is unchanged in this oblique collision question. So calculate in terms of E and U the velocity after. So we're looking for P and Q here. So we're going to have m by u cos alpha, mu cos alpha plus, it's actually minus mu cos alpha, this one times this one, is equal to MP plus MQ. So we're going to get P plus Q is equal to 0 in this case for the first one. Then V1 minus V2 over U1 minus U2 is equal to minus E. So P minus Q, we can just say is equal to minus E times, and U1 minus U2 is going to be U cos alpha minus minus, so it's going to be 2U cos alpha. And if we have P plus Q is equal to 0, we can say that 2P is equal to minus 2EU cos alpha. So therefore P is equal to just minus EU cos alpha. And if P plus Q is equal to 0, Q must be equal to the positive version of this, EU cos alpha. So their velocity in terms of E and U after the collision, P is minus EU cos alpha minus EU cos alpha in the I direction plus U sine alpha in the J direction. And for B, it's going to be EU cos alpha in the I direction plus U sine alpha in the J. We're told that A and B move perpendicularly after the collision. Show that E is equal to tan A. Okay, so what do we know? We know their slopes afterwards are the J over the I, or the change in Y over X. So the slope of A, or the tan of A, is equal to U sine alpha over minus EU cos alpha. This simplifies, the U's cancel, sine over cos is tan, so we have tan A over minus E. The slope of B is equal to U sine alpha over plus EU cos alpha. And this simplifies down to tan A over E. And if they're perpendicular, M1 by M2 is equal to minus 1. So tan A over minus E by tan A over E equals minus 1. So if we multiply by minus 1 on the tops and the bottoms, we're going to get tan squared A over E squared is equal to 1. So tan squared A equals E squared. So tan A equals E. And what we were asked, show that tan A is equal to E. So that's question 3.